All right, so it's how many distinct real solutions x are there to the equation? And I'm looking at, and it's really a counting problem at this point. So I have to count the solutions. I don't really have to get the solution to the problem. But looking at it, looking at the powers, it's 4, 8, 16. There's going to be 16 roots, by the way, all right? 16 roots, all right? So I'm going to say they're going to be real solutions over here. So, some could be complex, by the way, and the complex one would occur in conjugate pairs. So 0, 2, 4, 6, blah, blah, blah. Okay, let's take a look at it, see if we can figure it out. I go to the whiteboard, and the first thing I do is just, kind of write down what I'm seeing over here. I'm seeing, and it's really kind of like nightmarish to look at, x squared minus 1. It's typed up for you, though. And I would recommend, I find it easier to type things up than to write them down, by the way. Okay, the first thing I'd use the square root rule from that, and I'd get this over here. And the square root of 4 is plus or minus 2. All right, let me just try to solve that now. And what do you get there? Let's see. This would be 3 plus or minus 2. By the way, 3 plus 2 is 5, and 3 minus 2 is 1. They're both positive numbers, so I can use the square root rule again, by the way. And what do you get? X squared minus 1 squared minus 2 equals plus or minus the root of 3 plus or minus 2. All right, let me write that down now. So x squared minus 1 squared is 2 plus or minus 3 plus or minus 2. All right, I got to think about this now. This is the part where things are getting, is there a possibility of a negative number there? And I want to point out, looking at these things over here, it could be 2 plus something. And what could it be? It could be 2 plus, 3 plus 2 is 5. That's one thing it could be. What else could it be? It could be 2 minus the root of 5. Not so bad. What else could it be? 2 minus the root of 5. What else could it be? It could be 2, let's see if I'm doing that right, by the way. 2, I'm doing the minus now. 3 plus, oh, you know what? I made a mistake there. Just noticed it. Let me see that. 3 plus 2. Oh, no, I didn't. I'm sorry. Maybe I should erase this over here, though. Sorry about that. All right, what else could I get? I could get 2 plus 3 plus 2. I did that. Now I'm going to do 3 minus 2. What's that going to be? 3 minus 2 would be root 1. And over here you get 2 minus the root of 1. Well, these are easy. This is just going to be 3, and that's going to be 1. I want to point out this one here needs to be thrown out because the root of 5 is bigger than 2, and 2 minus a number bigger than 2 is going to be a negative number. So I need to throw this one out. So now I got 3 solutions at this point. Let me write this over here. You get x squared minus 1 squared is equal to 2 plus root 5. You're going to get x squared minus 1 squared is equal to 3. And then you get x squared minus 1 squared is equal to 1. Let's just go through that and see what happens now. What do you get over here? X squared minus 1 equals plus or minus the square root of 2 plus root 5. All right? And what do you get there? X squared would equal 1 plus or minus the square root of 2 plus root 5. All right? Now, certainly, I hope you realize we got troubles over here, and I'll tell you what the troubles are going to be. The square root of 2 plus root 5 is definitely bigger than 1, by the way. So I'm going to have to erase one over here. So I'm going to say x squared. It's got to be a positive number. It has to be 1 plus this number. It can't be 1 minus that. It would be negative. And we want real solutions over here. So x over here would be plus or minus the square root of 1 plus, it looks nasty, doesn't it? All right, so that's, a solution to the problem over here. By the way, I'm still counting them, and I'm looking at this one over here. Let me do the next one. X squared minus 1 plus or minus root 3. And what do you get there? X squared equals 1 plus or minus root 3. And again, I have to realize that, root 3 is bigger than 1, so x squared only could be 1 plus root 3. So I got another solution to the problem. X equals plus or minus the 1 plus root 3. All right? So, wow. I still have to count, by the way. Oh, this one's being not that bad. X squared minus 1 equals plus or minus 1. And what do you get there? You get x squared equals 1 plus or minus 1. So you get x squared equals 0. And the other one you get is x squared equals 2. What does that give you? Well, this gives you x equals 0. By the way, it's a repeated root because it occurs twice, 0, 0. But I'm going to say distinct means it's just one time there. And what's going to be x equals plus or minus the root of 2. So from this one, I get 3 solutions over here. Let me just show you the distinct. Although this is repeated, it only distinctly is only one time there. This is 2 times. All right? Let me keep moving. All right? Let's do the next one. What do I see over there? I see 2 solutions over here. All right? Let me just point out what I mean by that. I'm seeing plus or minus the root of, it's a nested root, 1 plus root 3. All right, let's look at this one over here now. All right, looking at what I'm seeing over here, I'm going to say another 2 solutions over here, by the way. And what am I seeing over here? Plus or minus, I'm saying 2 of this nested thing over here, which is a complicated number, but I still got that. Now, so they said, how many are there? Just count them together, 3, 4, 5, 6, 7. All right, so I'm going to say 7 distinct real roots. By the way, there's actually 8, but there's 7 distinct because the 0 is repeated. What does that mean? There's 8 complex roots to the problem. We did not write those down. They were asking for distinct real roots. Thank you.